Okay, I think we're recording. Oh, I don't want to go to updates yet. No, bad. Okay. Hello, everyone. Welcome to the data science and data engineering meeting for, sure, you can close the door. Yeah. Maybe we should just watch the door if anyone's trying to get in. Yeah. That's fine. Okay, I'll just restart then. All right, hello everyone to the data science and data engineering meeting for September 15th. To start, we have a few updates. So we're going to have a new meeting time after this meeting for 5:30. We're going to move it back an hour because this meeting time conflicts with one of the foundations of data science classes, but it turns out that 5:30 also does that. So, you know, we can't win, but we're trying to get as many people as possible. We just got some complaints about that last meeting. We're going to start up a weekly study group for people to come in with their like data science problems or like statistics or whatever computing, and they can come in. It's either going to be Monday or Friday. I'm leaning towards Friday because that's kind of like the like, oh shit, like homework's due day. So probably Friday from the when to meet. It looks like the morning was the best time for everyone. We're still looking for a space for that. We might try to get this room for like, you know, tomorrow, or we could find another study space. Also, we have an official email. So that's ritdse@proton.me. We use Proton Mail because, you know, we're cool. And then we also set up a GitHub. So all of our tutorials and all of our code is going to be on that GitHub as well. We decided on a tentative schedule for the semester. You know, things can change. It's mostly going to change based off of like guest speakers and, you know, when we can like get people here, or based off of what the club wants. So our tentative schedule for today is we're going to do a Pandas and Numpy tutorial plus some career fair tips, because the career fair is next week. So we want to, you know, tell people, especially, you know, first years in, you know, the data science program who haven't gone to one of these career fairs, we want to give you a heads up on what to expect and what you should do. Besides that, we have a few more kind of meetings that are like general tutorials, because we want to give everyone the data science basics to work with before, you know, we really dive into it. But after I say we have our first guest speaker, we're going to really dive into the content for data science. So data cleaning and feature engineering, you know, exploratory data analysis, and then all the fun algorithms. But right now we're focusing on getting everyone up to a level where they can engage with those algorithms. There's also more to look forward to. If you, for some reason, you don't like the schedule we've made, we're also going to have social events, hackathons, and club projects. We'll announce those. We just want to leave those as a surprise, so you don't know everything yet. And the meeting format, we discussed this. We don't want it to feel like another class, so we don't just want to like give you like tutorials. We actually want it to be like, you know, interesting and engaging on a conceptual level. So we probably want 1/2 to like 2/3 of the meeting to really be like conceptual, like here's how data science is used in the real world, like actual application. And then maybe 1/2 to 1/3 of the meeting to be an actual tutorial, like, okay, here's how you do it now. So you know where this stuff has its place in the world, and you also get a feeling of like how to do it. So we're gonna start with career fair tips and tricks, because we've been to a fair amount of career fairs. And if you don't know what to expect, it's going to be kind of a bad time. I know my first career fair was basically talking to like 3 people in like 3 hours and not getting any interviews or anything out of it. So we want to kind of give you guys a heads up on what to expect. So first, we're going to, if you want to, you can go to Career Connect event, university-wide career fair, go to employers, and you can search up the employers ahead of time. I very much recommend this because there's like many tables, right? And you should get there early. Like it starts at like 10. You should probably get there at 10. I made the mistake of going there at noon once, and then hence you get an hour wait to talk to everybody. But if you get there at 10 and you know like where you're going, you can go to the Career Connect and look up the tables you want specifically based off of filters. and then just bam, 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 hit everyone probably in the first couple hours, you're gonna have a much better time than getting there in the middle of the day and not knowing, kind of meandering around. So yeah, it's on next Wednesday. Yeah, this coming Wednesday. Yeah. Yeah, so hopefully we'll see you all there. And I want to give some like talking tips to recruiters, right? You want to say something about the company when you show interest. If you go up to them, you know, and be like, "Oh, so what do you guys do?" You're done. They're gonna throw your resume away because you just went up to them like, "I have no clue what your company does. Can I work here?" No. So so just know something about the company you're going to talk to, and usually bring it up. Say, "Hey, I'm interested in this because you guys do this," and that looks a lot better than trying to like, "So what do you guys do?" And then you're like, "This person has no clue what they're talking about." Yeah. Um, and then, you know, focus on your relevant experience and why you're a good fit. So it's like, okay, you guys do this. Here's my, you know, background experience. I've done projects at school. I've had like maybe internships or research experience in this, and this is kind of in line with what you do. And for those of you who are grad students, it doesn't like hurt to say that you're a grad student, because they're going to meet a lot of like upstart freshmen who think they can like work at Intel or something. Like they're going to get a lot of those who are like, "Hey, I'm like a couple months out of high school. Can I work here?" And like, no, like please leave. But if you're like, "Oh, I'm a grad student," like, okay, you're actually establishing like some amount of credibility to yourself. And I've actually had people like perk up like, "Oh, finally, like I'm talking to someone who like might know what they're doing." So that doesn't hurt. So I'm going to go for a quick example. So for me, I'm interested in this company. I think it's H2 or HII. I should probably figure that out so I don't, you know, embarrass myself. They're a defense company. And so I'm going to go to their page, right, and then look up what they actually do. And I like them because they're using systems and autonomy, you know, cyber solutions and applied AI and ML. So, you know, that's all really cool stuff that I want to do. And then so after looking up their background, I'm going to be like, "Hello, my name is Lee Win. I'm a graduate student in data science." So first establishing like some credibility, I would say. I want to talk to you guys because of your work in AI systems for defense. So I'm like, okay, here's what you guys do, and here's why I want to work for you. And then my background is in computational nuclear weapons modeling for Los Alamos National Laboratory using machine learning. So I said, here's what you do, here's my background, and now I'm going to like put it together for them. So like, boom, like this is why you should consider hiring me. So I've done research in academia and national labs, but am looking to move into industry. So at this company, I'm going to call it H2, would let me transfer my skills into a new setting. So I'm like, I'm already qualified and I like what you're doing. Please hire me. That's kind of the general spiel for like my elevator pitch. That's kind of how I like to do it, and it's pretty effective. I got a couple interviews at the last career fair, kind of with this like general scheme, so I thought I'd share it with you guys. So you know, tell them your like what you like about them, tell them your background experience, and then you can tell them like how you would fit in. For me, it's like I already have done this. Just let me do it for you. Do we have like any questions about, you know, the career fair, what to expect, anything you want to know that I didn't cover?
For the international students, don't go to a different class.
Yeah, do not go to a a defense company if you're an interested. Yes.
Yeah, actually, I have experience in web application development. I want to put it that way that it should be relevant to data science. So, what should I do? Like, what is your?
Yeah, so you have background in web development, but you're trying to like transfer into data science. So if you are looking, like if you read up on a bunch of companies, you can search by filters, right? And you can search by major and also like topics. So if you search for everyone who's looking for web developers, and then maybe find like a data driven company, database company, and like go to them and say, "Hey, I know you guys need someone to crunch your data, but you also need someone with a background in web design," and then like I'm your guy, right? Because especially with data science, the downfall for a lot of people is domain knowledge. So like for me, I have an edge because I started out in physics in my undergrad and then I transferred into data science. So I have domain knowledge of physics, plus I'm having all these data science skills. So I talk to a lot of people, even like engineering companies, some people who need to have someone who knows like physical stuff, but they also need someone who can work with data. I'm like, I'm literally perfect for you. So you could find a company that needs someone who knows like web development or crunching data to put on a website, because you could like merge those two worlds. That would be a really good strategy for you, I'd say. If you get in early and you know like exactly the booths you want to go to, I would say four or five would be a good expectation if you want to stay there only a couple hours, if you're willing to like be on your feet all day. And then especially after the first hour or two, waiting like 45 minutes, an hour to like talk to everybody, then maybe 7 or 8, but it just depends on your tolerance for that, I would say. Anyway. Yeah, it's in the field house. It's like they fill the whole thing with like booths for employers and whatnot. It's really big, and like everyone like wants to start like at the beginning, but then that's where all the long lines are. So maybe like start at the back or something. You'll figure it out, I'm sure. Okay, so next we're going to move on to our Pandas and Numpy tutorial. And for this, you can go to our GitHub that we set up for this and pull all of our tutorials if you want to follow along, or I can just post these tutorials in the Discord so people can download them. Let me do that real quick. I'll put them in meeting plans, let's say. And this tutorial, upload files, Numpy tutorial, let's upload that. Make sure these aren't the solutions, okay. Yeah. Okay, so I just put all those tutorials in the Discord under meeting plans so people can have those if you want to follow around. Oh yeah, we need the, I should probably give you the data set too. Yeah, I told them to, and they're probably using it in their classes as well. So, and you can download, you can get different kernels for Jupyter notebooks. Like I tooled around that. Like I got like an R kernel and like a C kernel and like yeah, and like but in VS Code, because that's you're talking about the IDE, right? So I know maybe.
Okay.
Yeah, but Jupyter. Yeah.
I did this, but I didn't like it.
Yeah.
But it has more features than original.
Okay, this is annoying on Mac. Just giving everyone move this toolbar out of the way so I can, yeah, there we go. That's fine. I just need a Numpy tutorial. And I think we're done with the slides, so I'll just do that. So does everyone just have one of these notebooks? So as we said, the first couple of meetings are going to be kind of the like basics of data science before we can move into like, we want to move into like the really cool algorithms and stuff, but we also want to make this very approachable. So we're starting from the bottom up so we can give you the tools to actually like do this stuff. And I would say some of the bread and butter packages you're going to use in Python are Numpy and Pandas. These are really good data structures and data wrangling tools that are used all the time. I think I use at least Numpy every day for every single data science project I've ever done, because that's just how useful it is. So the good thing about Numpy is it basically is a data structure set around the Python list, and it makes them much easier to work with. It also makes them much faster. They're basically vector magic. So sometimes if you do things with lists in Python and then you translate it into like NumPy objects, you'll get like orders of magnitude of speed up. So keep that in mind. So first, we're going to start with importing our package, NumPy as MP. You can use MP as your moniker, so you don't need to keep on, typing out NumPy dot whatever. Just use MP. And now we're going to go into like how useful like NumPy arrays are. Let me just zoom in real quick. Yeah. So first, it's useful if you want to do actual like math with lists or like kind of like lists of like objects or numbers. So if you use the basic Python objects of a list and like you try to do this, you will get an error because a list object in Python, you can't like do math with it. But let's say you want to actually do this operation, you would need to iterate through the list and do it element by element, which is quite cumbersome and it'll also be slow for you. But let's say we do the same thing, except we cast our Python lists into a NumPy array. So these are the exact same lists as we had. We just kind of wrap them in a NumPy array, which will be vectorized for us. And we can run this. Oh, NumPy is not defined. I thought I ran that. Okay. And now we can do this. And here, boom, it does all of that calculation for you. It actually does go through a loop and do it element by element, but it's all internal and it's all baked in with like C code. So it's like much faster than you could do with Python. And what's also useful is there's a bunch of built-in NumPy functions, especially when you want to do like statistics or just any type of calculation. You can just take your list here and be like array. So here's my array. So array.sum, array.mean, standard deviation, max. So you can just like take this, set of objects and say, do these statistics on it. There's also more functions like mathematical functions, like you can do like trigonometric functions, exponential, log, and it will log every element in that array for you. So super handy. It makes just doing like math and stuff on lists or like, most data sets are like, column based, like, you have time and response. You cast those as NumPy arrays and you can do all the statistic stuff on it like really fast. I think where it shines the most is actually with multi-dimensional arrays, because if you have a multi-dimensional array as a generic Python list, it's a pain in the ass to work with. Like I just want to add these two matrices together. So I need to write this, nested loop structure there to add it element by element. But hey, let's say I just do the same thing, but in NumPy, then it's literally just one line. Instead of a double loop structure, I literally say, hey, add these together, and it does it for me. Same thing with the one-dimensional arrays. With two-dimensional arrays, it'll do the exact same thing. You get the sum, the mean, the standard deviation, the max, all for you. So it's, yeah, we're just kind of showing you how useful this tool is. Now we want to know how to like actually work with these arrays or get your data out of it. So we're going to go into array indexing and slicing. So by indexing and slicing, I mean like how do you get a single value out of these arrays, or how do you get a column or row out of the arrays? So for indexing, it's pretty easy. It goes row by column, starting at 0. Always remember that. So if you want the very first element, like if I want this 1, it's at 0, 0. I usually think about it as like coordinates, especially with like, 2 and 3 dimensions. I'm like, I want the 0th row, the 0th column, and like, let's say that it's 3-dimensional, like 0th depth. And so you can see here, if I want to get, a bunch of, vectors or not vectors, numbers out of it, like I want the middle number, then I'm going to go 1, 1, because remember, we're indexing at 0. So 1 is second row, second column, and now we'll get us the 5 here because it's the middle of our array. To get the last one, right, second or third row, and then third column, or alternatively, you could use -1, 1. In Python, this is the shortcut to get the last index out of something. It's with -1. You can also get entire rows and entire columns out of NumPy objects. So here I'm just getting the rows out. The rows are kind of like your first coordinate in this. So if you just give it, like here, we're specifying row column, but here, if you just specify row, then here you get the row. And here to get the columns, you kind of do the same thing, except you need to use this colon value. The column tells you to like get all indices. It's like get everything in this span. So I want like the first column, I give it like the 0th column, the first column, and the second column. And this gives me all of my columns out of that. And I actually did a transpose on it because I printed out all the columns instead of all the rows. But with a NumPy object, you can actually just tell it to transpose. This is a very useful thing to note, that dot capital T, it will just rotate, a matrix for you. So another good thing to know is how to mask out arrays. So masking is literally just like filtering out subsections of the data you want. So like for here, I have some negative and positive values. And let's say I want to get all positive values out of this, excluding 0. So what you do is you need to make a mask, which a mask is just a logical statement that's like telling you like what you want. So here I say, hey, get me array greater than 0. And if I print the mask out, it's a bunch of true and false values. So everything that's below 0 or 0 is going to be false. Everything above 0 is going to return true. And if I feed this mask, usually we give it like an index or something, but no, this time I'm giving it a mask. I'm saying, hey, give me everything that's true in here, and it'll give me all the positive values out of that array. And this is super useful when you're looking at data. Be like, okay, I want everything, above, below, or maybe equal to 0. And it's definitely something that I use very often. We can also do this with like non-values or like null values, where NumPy has a baked in is non-value. So I have this array here, it has some non-values. I tell it to tell me where are the non-values, and that will be my new mask. So this mask tells me it's true where non-values exist. And if I use this tilde here, it's actually like a negation. It flips every like, Boolean like argument. So it's flipping this from all the falses and trues, and that'll give me everything that is not a non-value, which can be useful if there is like missing values in your data and you're loading in with NumPy. Be like, okay, I don't want the missing data. Just give me every indice that's like actually filled in. Speaking of data, how do you actually like do something with it? How do you load in data? How do you manipulate it? So here we got a basic data set for, it's a bunch of like serial, basically. It's like the serial and a bunch of features that are like, I think it's the nutritional value, like the weight per cup and the name of it and the manufacturer. So here, most commonly used is NumPy has like a load text, and you can load in a CSV. Make sure to give it a type as a string because there's words in it. So default every data type here to a string, which you need to look out for, because if you keep it as a string and then try to operate on it, you will throw errors, because it's like, how do you subtract like 2 words from each other? It doesn't work. And also when you're loading in a CSV, you got to give it a delimiter, or basically how are the words separated. In this case, in a CSV, or comma separated, right? You got to give it a comma as a delimiter. And on your own time, if you want to play with everything I've shown you here, like all the functions, all the slicing and masking, you can go with your own data exploration, load in the serial data, and then try to like analyze it and answer questions about the data. And if you can do that and you don't have any problems with it, you've basically mastered NumPy. There's a lot of functions in it. I don't even know all the functions. I just look them up. So, looking at documentation always helps. So next, we're going to look at Pandas, which is another Python package that's similar to NumPy. It's basically a wrapper for data structures, but it works kind of in its own way. And Tolu will give you this this tutorial. So.
Hey everyone, thanks for coming again. This is going to be Pandas. So long story short, every time you work with like an Excel kind of like data file, you have like all these grids and columns and rows, and you have it inside it's called tabular format. So how do you like just read this into like Python for you to like operate on it, to do some calculations, to like just select different rows and columns, or even like spreadsheets. If you guys have like worked in like corporate, you maybe have done some like pivot tables. So Pandas is actually this library that gives us like a bunch of functions, and it allows us to do this really easily as compared to like writing up formulas or functions from scratch. So when you guys see this, so we're going to post this again to a GitHub. You guys will always have access to it. So, you know, let's say, for example, you miss a meeting or you want to review something after a meeting, you'll always be able to see it. And so this is just the documentation for Pandas. Okay, cool. And if you access it, you can start to look into it and see what kind of data does it handle. Like I mentioned, there's data frames, different columns. And when you actually like dive deeper into it, there's different tutorials, there's different functions that you can look into, but that's for like a different day. As for now, let's just run through a couple of different examples. So first things first, we're going to import it. Importing Pandas as PD is what I generally do, just because it's easier to call it by this like little 2-letter moniker. So we're going to run that, and then we're going to say, well, we have a serial data set. It's serial.csv. Whenever you have a data set, always make sure it's in the same folder as the code that you're running. So it's like easy access. And so you can just, again, there's a function in Pandas allows you to easily read it. It's called pd.read_csv. It allows you to read XLS like files and a whole bunch of other files. So it's like really straightforward. So we're gonna read it in. And also when you see this number to the far left, it just means that you've run the cell. So here we're gonna run this. We're saying, hey, we wanna see the first 10 rows of this data set and show us as many columns as we possibly can. So that's the head function. And there's also, on the other hand, a tail function. We want to say, hey, we want to see the last 10 rows of this entire data set, and we want to see as many of the columns as possible. So in this case, we can say, hey, we want tail to be 10, but notice, obviously, you can change this. You can say, hey, show me the last 25 rows of this data set. It's not going to show because it's like really long, or actually, no, it does. Okay, so it'll show you like the last 25 rows. You can put any number. I think it defaults at 5. Yeah, it defaults at 5. So if you put no number at all, it'll just give you the last 5 rows in this context. So now how do we slice and like pick like specific values of a data frame? Well, this is how. If we want to say grab just one of the columns in our entire data set, we'll say, hey, the name of the entire data set, as we've called it, which we've called it serial, and we want to grab the name column, we'll just put the name column in brackets, and we put it as a string, and we say run it. Oh, by the way, in order to run this, I'm doing Shift Enter on Mac. There's a lot of hotkeys that you can learn when you're running through these Jupyter notebooks. For example, let's say you want to create more cells. You can just literally click the cell that you're currently on. You can press A. It's like above. You can just add new cells right above. If you want to get rid of some cells, you have to make sure it's like highlighted right here. You press the letter X, and it'll just like delete them. If you want to add something below, you press the letter B. If you want to change it to markdown text, so let's say you don't want to write code, you want to say some kind of memo to yourself. And this is how you write a memo to yourself as compared to writing code. So as we like go through the weeks, we'll give you guys some like little tips and tricks on how to like make this environment like really easy for you to use, and just little things I guess aren't really spoken about in your classes, and it'll make it like a lot easier for you when you navigate through like different assignments or maybe like pet projects that you have. But yeah, so you just click, you make sure, okay, so when you're typing text, it'll be green. You see how it's highlighted green. So you have to make sure that you just click like the cell itself, like press the word in, and when it's blue, you literally just press the letter M, markdown. And then you can start typing. And again, you can just write it to yourself. If you want to just exit out of it, you make sure it's highlighted blue, you press letter X, and it's gone. Sweet. Oh. What's the hot button to run? Oh, hey, Megan, how are you? It's a hot button to run code on Mac automatically in Jupyter. as opposed to hitting run each time. Yeah, so again, yeah, it's shift plus enter at the same time. Or
You can do either. Usually.
yeah, I do shift.
So shift enter keeps your focus on the card itself.
Or-
Command enter keeps the focus on go down.
Yeah.
So if you want to run through the whole code, you should go down.
Yeah, sweet. All right, so let's just keep on navigating. We have quite a few cells, like we have a bunch of things left, so let's keep going. Let's say we want to say, okay, so we just grabbed the column name, right, inside this data frame. Let's say I just want the first item of this, column, right? So we're going to just add the first element. Simply say, hey, we're in the data set serial. We want the column name, and then we get the 0th index or the first element of it. So then we just run it and we say, hey, it's going to be 100% brand. And as you see, that's exactly what it is. Let's say we want multiple rows, or actually this should be multiple columns inside the data set. And they don't have to be, next to each other. They don't have to be close at all. Simply, you just write the data set that you have, you'll put brackets, and then in another set of brackets, you'll put, in a list comprehension, you'll put all the columns that you want. So then, we have name and sugars here, but let's say we want more than name and sugars. I love going to the gym and I want to see, is it protein? I want to see protein, and I want to see salt because I'm looking after my health. So sodium. So we can just grab any random columns that we want from the data set. Now, when we want to identify rows, on the other hand, there's different ways to do this. iLoc, it stands for integer location. It just means that, hey, we want to look at all the rows and we're going to number them. And so the 0th row, as you guys know in Python, would be the first row. And so we're saying, hey, we want the first row inside this entire data set. So in this case, it's going to read as like a column, kind of. Like you'll see that all the column headers are like listed on the left. And so, yeah, this gives us the first row of data. But I believe if we add another bracket, it'll give us in the horizontal. Yeah, it'll give us the horizontal format. So it's easier to see for us. And again, we can do multiple different columns. We can say, hey, give me the give me 1, 2, and 3, which is second, third, and fourth rows. We can just grab them just like this. And there's a lot of different things we can do. There's a lot of acrobatics in Pandas, which makes it really fun and like a default library to know. But we'll keep going. So now we have some Pandas functions. So just like Numpy, Lee showed us like a really, really strong example of how you don't always want to like write things from scratch. You want to like make things easy for yourself as much as possible. So Pandas has a bunch of built-in functions that will make life just like really, really easy. So you can just progress through your projects really fast. So let's say, for example, I want to find all the unique names in this column. And maybe when you have a data set, there's going to be like a lot of redundant names, a lot of redundancies, for example. This is a really easy way to just see, okay, how many actual names do we have? Well, not how many, just like the names, like the unique ones that we have. So it's literally the function .unique after the column that you want. So we'll say, hey, give us the unique names inside this column. And let's say we want to find any NA values inside this data frame. We'll say, hey, give us the name of the data set. And we're saying, hey, if there's anything that has an NA value, let me know. In this context, we see that none of these are NA, but certainly when you're going through your data sets, you want to like look into and find all the missing values, all the null values, all these little things, because before you even like get to machine learning and running your data into these algorithms, you want to make sure your data is clean. In fact, that's a lot of the job is data. You'll find that in certain contexts, you'll be doing a lot of data cleaning. That's not necessarily the job of a data scientist all the time, but it's really good to know how. You know what I mean? Data engineers, they kind of do feature engineering and data cleaning. But I will say that, the more versatile you are, the better off you'll be. And this is something standard. So it's something to know. And so moving forward, let's say I just want to see in one particular column what the NA values are. I would say, hey, give me the name of the data set, give me the column in particular, and tell me if there's anything that that's an NA value. As we see, this is all false, so we're okay. The same is true for null. You might have some null values that you can't see because some data sets are like so large, you can't like tease through every single cell. We'll just do this and it'll tell us what we need to know. Now, moving into like, I guess, more colorful stuff or useful, well, maybe not more useful, more colorful stuff. We want to see some basic stats on all the different columns that we have. So we say, hey, I want you guys to show me the count, the mean, the standard deviation, the different quantiles, the min and the maximum values with respect to every single column that, I mean, obviously has numbers on it. We can't necessarily do this with like, I guess, categorical variables. We want to say the dot describe method. This is like one of the most standard things. I've used this very often, is give us like a quick read on the statistical breakdown of what we have. So there it goes. If we want to see what type of objects that we have, we can say, give me some information about my data set in general. This is before you even get to like, again, machine learning or, you know, data visualization. You want to get a feel for what it is you're even working with. And so these are like some basic things that everyone will probably be using. So .info is a function that tells you the column name, it tells you the non-null count, and tells you the data type. So we have some objects, we have some integer values, we have some float values, and these are pretty useful moving forward. Data D types just gives us the object names, and let's say we want to know how many rows and columns we have. We can use dot shape. Dot shape makes it really easy to say, hey, we want to know what we have. This is telling us we have 77 rows. We have 16 columns in this context. Also, one thing I just thought of, let's say I have data, right? And it's in the form of an int. And let's say I want to change the data type. How will I do that? So let's say, for example, we have calories. And I want to change this to a different data type. Is it? Yeah. So now what we did was we had this in the format of integers. We changed this to floats, which is, you know, values with decimals moving forward. This is actually like, it comes in handy very often. And you guys will see this, I'm sure, as you go through like your assignments and little projects. So now let's just look at how we can integrate these two things together. Again, Pandas and Numpy, they like are the most standard libraries you'll be using probably. And so we should know how to do some basic things. So let's say we have some missing values, right? We want to kind of work with our data set. So here I'm going to just import Numpy. And we have some data. I'm going to make a quick little data frame or data set here. And now I'm going to turn that data set into a data frame using Pandas. Now, this is basically the structure of what I just made. We have 3 columns, we have 3 rows, we have some NaN values, we have some numbers. We have a float in here as well, so it's pretty like straightforward to see. And let's say I want to drop some rows, some things that might not be particularly useful to me, or some things that I see I don't necessarily want to deal with. In this case, we want to say we don't drop all the rows with NA values. And so it's as simple as saying, hey, I have a data frame, I want to drop the NAs, and this is a simple function to do that. Let's say I only want to drop the columns that have an NA value in them. Then we're going to say, hey, drop df. This is our data frame. We're going to drop the NAs, and we're going to call our axis 1. Also, another little quick tip is if you actually go inside like the first parenthesis of like a method and press Shift Tab, you'll see this little thing. If you press it again, there's like a drop down. It tells you all the parameters of your function. So it tells you exactly what it's asking for and exactly what it's going to be used for moving forward. So it's kind of like an easy way to, if you don't know everything there is to a method, you can literally just like find out right here, as compared to maybe going on Google and saying, you know, what is, you know, drop NA's parameter values. You always have quick access to it here if you, again, press Shift and press Tab. So it's another like quick little trick you can use. And so we're going to drop the axis, we're going to drop the NAs. And so let's say we want to keep so we're going to drop some more NA values, right? But we want to keep any form of any row of data that has at least 2 like real number values or 2 real values. And if it has fewer than 2 like real numerical values, then we just want to drop that row. So stated differently, we have 3 rows here, right? We're saying our threshold is 2. So we see that in this column, in this row 1, we have 2.0, NaN, and 5. Our threshold is 2. Because this has 2 values that are not NaN, we're going to keep this, and anything else that doesn't, in this case, the second row, we're going to just drop it. So we try that here. And again, we're just going to keep everything that has 2 like numerical values. So moving forward now we want to know Like, what if you have missing data in general, right? What if, you know, what if you have like empty values? What if it's like a 0 and there should be something else? Well, there's a couple of different approaches to doing that. So dealing with that, one thing some people will do is like leave it empty depending on the problem, or there's something called imputation. So there's a way to like generate data in case you're missing some data. And let's say you're dealing with numerical values. Let's say you're missing, you know, there's some cells that are missing. Sometimes people will take the median and just input that median value instead of the 0 or the missing value. Sometimes people will take the mean of that column, for example, and they'll input that mean inside where it's like a missing value. And sometimes people will just remove column or rows with missing data altogether. Like in each use case, there's a different time to use each like method, and it's kind of like you kind of have to feel it as you go along. Sometimes people remove rows, but you don't want to do that all the time, because if you remove too many rows of data, it's going to remove like how much data you can even work with for your machine learning model, and that can be really bad. So again, you kind of play it by ear depending on your situation. But let's say we want to fill our NA values, right? So what we can do is there's a function called fill NA, and it's going to say, let's say, for example, when to say fill this value. I just wanted to type this out so you guys could like literally see where it would go into. And so we can say fill this value. Let's say we want to fill it with a number 20. We're going to all the places where there was an NA, we now have the number 20. So obviously this is like a 3x3 matrix, but when you're working with like really, you know, large data sets, maybe like 100 rows and like, I don't know, 50 columns, for example, you're not going to be able to see every little instance. So the power of this is that it'll do all these little cleaning checks for you in, you know, half the time that it would take you to manually like go through something. And I think that's kind of like anytime where you can save time or cut some corners, it's something that should be considered. So I think that's pretty helpful to know. And again, we're just gonna run this column here. Oh wait, that's okay. Kind of skipped over this. So let's say we have the first column. We want to fill in any NA values with the mean instead. This is called method. No, this is not method chaining. This is something different. We're basically saying, hey, we have some NA values and we want to fill it with the average of this column instead. Like I just told you, sometimes you use the mean. So that's what this piece of code will do. It'll just replace it with the average. So we have what? Originally we had, yeah, 1 second, I'm just making sure. Okay, I don't want to do the mental math, but I'm pretty sure it works out. So we're gonna keep going. Lee mentioned masking. This is how we kind of like, if we have like a lot of zeros or a lot of trues or falses, we can kind of just like replace these values. And so NANs are being replaced with 1000 in this case. Here we're creating a new data set and we're saying, hey, we're gonna mask any NA values with the number 50. So here you'll see like there's 50s right here, and right here, as well as here. And there's a direct consequence of this masking. So we're almost done, guys. Hopefully you're still with us. There's something called group by, which is something that's really useful. If you're taking the SQL class, I forget the course code, but it's like a required class, databases and design, like, okay, there we go. 608, ISTE. You're gonna learn something called group by. It's like super powerful. You're not gonna get out of that class without knowing this. So you're welcome. I'm showing you this in advance, and this is something you're gonna use. So it's something to know. In SQL, it's basically like you wanna operate on like, you wanna group different rows based on columns, and you can kind of like do like, you can do like functions on them. So this is a good example of that. Let's say I wanna make a quick little data set, and this is gonna be like stock data, right? So we have a company, we have people who are like doing some investing, and we have sales. So we created the data, it's called data 2. And now I'm gonna turn this again into a data frame using pandas, pd.dataframe. So now we're just gonna look at it. df2 is right here, and we're saying, hey, this is the company Tesla, this is the company Google, this is the company Apple. We have 6 different people, and well, I probably should have said shares. Okay, this is how many shares we have of each, right? So now we're gonna say, hey, I'm gonna group this by different companies. So when I just do this, as you see, it's not really giving me some output. It's just telling me where it's being stored in memory, right? And so what we want to do is we want to assign this group by the company into its own variable, which we do here. And we're going to say, hey, give me the mean of each of the different companies. Well, the mean of the shares, basically, I believe it is. So if we do some quick little math, Tesla, we have what? 150 plus 250 is 400. And then we're taking the mean, so it's 200, right? Because it's 400 divided by 2. And then we're just like, basically, we're doing the mean on each of these different companies based on the amount of shares that are corresponding to the people who have invested. Now we're going to take the group by, we're going to take the sum. So we're just going to add basically within like the same company. Again, we have 2 rows of each company. We're going to take the sum of the amount of shares because we're grouping them by the company. This is like, hopefully that's clear. Here we're taking the standard deviation. It's like an easy way to like find these little values once you group them together. And let's say I just want to find the sum of Tesla in itself. Like we've already taken the data, we've grouped it, we're taking the sum, and we want to find like with respect to one company now. And so with Tesla, it's just saying group by, taking the sum, and we're taking loc. Loc is just location. By the way, this is called chaining. When you put 2 methods, one after the other, it allows you to like kind of like subset like exactly what you're looking for. It's like it allows you to get really specific with what you're looking for. So this is me saying, hey, how many shares are being invested in Tesla? Boom, we have 400 right there. It's pretty quick and easy to see. And there's another way to do this. We can say, hey, DF2, that was the original data set. We want to group by the column company, or yeah, the column company, and we're taking the sum, and then we're locating the company Tesla. This is the exact same output. This is just a little cleaner. So I just want to show you guys a little difference right there. And these are just honestly just different ways to use group by to find just different relationships. Again, this is a small like data set. It's like really like easy for us to work with. But when we get like progressively bigger and bigger, using these and understanding these on an intuitive level will allow you to like slice through data and make like some really quick calculations in no time, which is why it's pretty powerful to know and to use moving forward. So this is me taking the count. This is me taking the max. This is us taking the described, as we mentioned before, some basic statistics on each of the companies after we've grouped them. And this is me saying, hey, transpose this information. So transpose, I don't know if you guys have taken linear algebra. It's just saying if we have rows and columns, we just want to like swap them. So that's all this does. As you'll see, before we had Apple, Google, and Tesla on the left-hand side, and the statistics were on the like in the columns. Now we just swapped it. That's what the transpose will do for us. And so if you're interested in a single company, you can just say, hey, we want to take the data set, we're grouping it by company, we're taking the described, we're transposing it, and we're taking Tesla. This is how you get this is how you get really specific, and just something really quick to know. I believe this is gonna be our last segment, merging, concatenation, and joining. We can take a quick breath. I know I need to. But, long story short, this is also gonna be in your SQL class. I figured it's like a cute little way to just like sneak this in while you guys are maybe like first year, so you can like get a quick like glimpse of what it is. But merging, concatenation, and joining, not only in SQL, but even in the context of like just knowing like how to operate on different data sets, how to merge different tables together, different matrices together. These are like useful things to know moving forward. So let's create like some cute little data sets called data 1, data 2, data 3. I'm going to create an index, some first names, some last names. Data 2 is going to be, again, an index, first names and more last names. Data 3 is going to be an index and some ID numbers. So we're going to shift enter again, just for Megan. And then we're going to create some data frames so that it's easy to read in and work with. So again, I'm just saying, hey, PD, pandas, give me the data frame function. I want you to take, so these are some of the parameters. It's going to take in data, index, the columns, the D type, and the copy. By the way, if you don't, so in the first example, I'm saying data is data 1. Index, I don't really have an index yet. I didn't mention it, so it's kind of like they'll read it in if I do input it, but if I don't read it in, they'll just ignore it. And we have columns here, so it's going to create my data set accordingly. And I also put D3 just because I want to see like what my new data set is going to actually look like now. I just made something. I want to take a quick peek at it. So it's pretty easy. And so now I'm going to say, hey, I want the quote unquote total data. I want to put two different data sets and I want to put them together so it's like easier for me to work with. So total data is going to be the concatenation of D1 and D2. So basically, again, these two things, data 1 and data 2, we turn them into Pandas objects, D1 and D2, and then we combine them, boom. Now we have this beautiful total data column with these random names. And let's say we want to continue just doing some concatenations. We have this output. We want to merge total data with D3. This is the last little data set I made. And so it's going to be on index. Whenever you join, you have to give an on label. It's basically like the columns. It's the column that the data sets will have in common. So it's like you'll just add them together. And so basically, oh, well. Okay, yeah. And again, we're just going to run this on the last piece of data that we have. Okay, cool. So long story short, we've done a couple things today. We've merged data. Actually, I don't remember everything we did. So let's let's go back to the top. We learned how to read in data. We learned how to slice an index to find specific rows and columns that we want to get. We wrote a beautiful memo to ourselves that this is a great club. You guys should always come Thursdays, 5:30, 6:45 p.m. It's actually going to be in this room moving forward. So please attend. We'll have more things going. How do we grab certain values from the data set? That's one thing we covered. We looked into some basic Pandas functions. What do we do when we have NA values? What do we do when we have null values? How do we look into some basic statistics whenever we have a data set? How do we look into the info, like the data types that we have? Then we wanted to look at how Pandas and Numpy are used together. Again, these are some of the most basic libraries you'll ever use moving forward as a data scientist or person who just does some data science. These are good to know. When we have missing values, what do we do with them? How do we drop different rows? And generally speaking, there's also, grouping your data by different columns or different rows. How do we do this? As we said, it's the group by. There's a bunch of different ways to operate on grouped data, standard deviation, there's the max, there's a count, there's a sum. And then finally, we got to merging, concatenation, joining. Whenever we have data sets, sometimes we want certain columns, we want to add them together because there will be cases where we want to like do a certain special analysis. And so it's just good to know these basic things. Again, everything that we're going to do is kind of going to build upon these basic fundamentals. So moving forward, if this was too much, if I've said too much, if for whatever reason you guys got tired along the way, we are posting this online, so you can kind of like look at it on your own time, go through it at your own speed. And again, at the top of this entire notebook, there is the documentation. Whenever we, even as second year students, have to do things, we don't memorize all these things. Like we kind of just like have a loose idea of what we want to do. And sometimes we just like know how to do it. But often it's the case that we'll Google, how do we do this? How do we do that? And you'll find yourself going to this documentation website. So it makes sense to just put it in the beginning for you guys to see, and you guys can just like find a whole bunch of functions that you're like, I can guarantee you're going to use down the line. So just get familiar with this documentation. And there's Numpy as well. Get familiar with the documentation. Whenever you're going to Google these things, you're probably going to get right back to here anyway. So this is just a good way to get familiar. I'm going to leave the exercises to you guys to do in your own time, just because we did pass 7:30. And so on the DSC Discord, there's something called a DSC exercise problem or something like that. I think it's what it's called. You guys can look into it. Some of this stuff has been inside this tutorial. Some of the stuff you'll probably have to Google. We'll release like the solutions. If you guys want to talk about it at some other time, feel free. But that is all we had for you today. Oh, yeah, Oh, okay, yeah. First of all, Megan, glad you liked it. Thumbs up. I will post this on the Discord. Yeah, we got to chat about that. But yeah, everyone, that's all. Thanks for coming again. We're still obviously filling things out. And so please work with us, please work with us, please continue to come back. And also tell your classmates, your course mates, to stop by. Again, these are going to be the people you're going to be in classes with anyway. So you might as well introduce them to the club, invite them to the club, start working with them, start seeing them. Because again, the people you see in this classroom, at some point, you're probably going to take a class with. So good way to meet people, good way to network, and good way to get some more extra practice. So yeah.
Do you have any questions on anything we covered today? Or if you have any, you can post them in the Discord.
Yeah,
There's a lot
just
of
post them.
knowledgeable people.
Yeah. So that's all. Thank you guys again, and I will stop. Sure. Yeah. Oh, Megan, YouTube.
Stop recording.
Yeah. Stop. Sure. Sweet. All right.
Okay. Yeah. Next week we'll be doing the same thing like this, but with like Matplotlib and Seaborn.
So we need data visualization.
Data viz, right? And everything's going to build off of, everything. So we're going to be using Pandas and Numpy, next meeting and every meeting after. And that's going to be the same thing. Right now we're building up the basics, and then we're going to get into like really cool algorithm stuff. But we need to make sure you guys have the tools first, and then, and then we'll have some real fun.
We really do want to get